In this video, we're going to talk about table of variations or using the first derivative test. So to do the table of variations, you need to start with these steps. Step number 1, we need to find the derivative. Step number 2, you set the derivative to be 0 and find the roots. So find all the x's that make the derivative 0, and these are called stationary points or stationary values. Step 3 is to do the table of variations by checking the sign of y prime, the derivative. Let's see an example. So let g of x equals x cubed plus 3x squared plus 3x plus 1. We need to check if this function has a local maximum, local minimum, or maybe a saddle point. Now, the first step we need to derive. So g prime of x equals 3x squared plus 6x plus 3. Step number 2, I need to mention that g prime of x equals to 0. Then 3x squared plus 6x plus 3 equals to 0. Now either you use calculator to get the roots or you can factorize. So in this case, if you factorize, you take the 3 out and you get x squared plus 2x plus 1 inside the parentheses. Now this is the same thing as x plus 1 all squared equals to 0. Now if you have two factors multiplied equals to 0, it means either the first is 0, however 3 here is not 0, or the second is 0. So in this case, x plus 1 squared equals to 0. It will lead to x plus 1 equal to 0, then x will be negative 1. So only we have one stationary value. Now, this is a polynomial function, so it's defined everywhere, from minus infinity to plus infinity, or we can say for all real values. So it doesn't have any restriction on x. You can substitute instead of x any number you want and still you can get a y value. That's why we don't have any restriction. Now to do the table of variations, you write x, then the derivative, then g of x in this order. Now the function or the values of x are from minus infinity to plus infinity, and we have only one value here, which is negative 1, that makes g prime 0. So I just make a line or a segment on the level of g prime and I write 0 there. Now what is the sign of g prime of x between negative infinity and negative 1? You can pick any value here before negative 1, so let's say negative 2, and replace it in g prime of x. When you do that, you will get 3 times negative 2 squared plus 6 times negative 2 plus 3, and the answer of this will be equal 12 minus 12 is 0. The answer will be 3 positive, and we can pick a value after negative 1. So you can pick 0, you can pick 1, whatever you want, and replace it in g prime of x. When you do that, you're gonna get plus. So in this case, our function is going up, then up. When the function goes up and up, it means g prime of x does not change the sign over that value of x. It means the function does not have local maximum, does not have local minimum. In this case, we say at x equals -1, we have a saddle point. Now, let's check another example. If this is g of x given to you and the question is find if we have a local maximum, local minimum, or a saddle point, again we need to do the same steps. So g prime of x, using the chain rule, the 3 goes down. So we're applying this rule. If you don't remember, the derivative of this is n u exponent n minus 1. We have to multiply by u prime. So it's x squared minus 6x plus 8 exponent 2, but we have to multiply by the derivative of what is inside, which is 2x minus 6. Now, g prime of x equals 0. This is the second step. It means 3 multiplied by x squared minus 6x plus 8 squared multiplied by 2x minus 6 equals 0. So we have product of factors equal to 0. It means either the first is 0, or the second is 0, or the third is 0. Now we're sure that 3 is not 0. So either x squared minus 6x plus 8 squared equal to 0, or 2x minus 6 equals to 0. For the first one, if we have something squared or cubed, we don't care, just we take what is inside the parenthesis to be 0. Or 2x equals to 6. So for this one we get x equals to 3 is the first stationary value. And for this one, if you have calculator, you can get the roots or you can factorize. So I want two numbers, their product is 8 and their sum is -6, and they are -2 and -4. So either x is equal to 2 or x equals 4. So in this case we have 3 stationary values. Let's check what will happen. So now we do our table operations, g prime of x, g of x. Now for this function we have no restriction on x, so our domain of definition is -infinity plus infinity, or we can say all real values. Now we need to write the stationary values from smallest to largest. So I start with 2, then 3, then we have 4. So the first value 2, it will make g prime 0, 3 will make g prime 0, and 4 will make g prime 0. You can see that. So when g prime of x equals to 0, we have the values x equals 2, x equals 4, x equals 3. Now choosing values from -infinity to 2, from 2 to 3, 3 to 4, 4 to plus infinity to check the sign of g prime of x. You can choose the value 0 if you want here, or 1, or -1, or whatever. A value here that is like 2.5, 3.5, and a number bigger than 4 that is 5. Now you go back to g prime of x, which is the one we did here, and you replace these values. We don't care about the number we get, just we check the sign, if the number is positive or negative. When you replace 0, you're gonna get a negative answer. When you replace 2.5, you will get negative. When you replace 3.5, you will get positive. And when you replace 5, you will get positive. So in this case, the function is going down, then down, up, then up. Now, what does this mean? It means at x equals 2 and x equals 4, we can see that the sign of g prime of x is not changing. So in this case, we say we have saddle points. So we have saddle points. Now, if you want to find the y value, you can go back to the main function g of x and replace in g of x the x value to get the y value. And as you can see, at x equals to 3, we have it's going down, then up. So we call this a local minimum. So at x equals to 3, the function has a local minimum. Again, to find the y value, you go back to the main function. Now let's look at this function. We can see it's a polynomial, so it's defined from negative infinity to plus infinity, or we say r, or real values, because no restriction on x. We do the derivative, we get 12x squared plus 6x minus 6. Then g prime of x equals to 0. It means 12x squared plus 6x minus 6 equals to 0. Either you factorize or you use calculator. In this case, we're gonna get two values that are x equals half and x equals -1. Now please pay attention while doing the table of variations and write the numbers from smallest to largest, because some students, they tend to do this, half then -1. No, it must be from smallest to largest, otherwise it will be wrong. So -1 is smaller, and these values will make g prime 0. So you just make the segment on the level of g prime and you write 0. Now there is a trick here to do it fast. If this is a quadratic expression, so the highest value of x is exponent 2. So if you have the highest value of x is 2, then the sign between the two roots, which are -1 and half, it will be opposite to the sign of the leading coefficient, so the coefficient of x squared. So if 12 is positive, then between the two roots will be negative, and on the sides it will be opposite to the middle, so plus plus. If you don't like that, you can pick a number before -1, for example -2, replace it in g prime, you will get positive answer. Between -1 and half, you can choose 0 if you want. After half, you can choose 1, 2, 3, whatever you want, and you will get positive. So basically the function is going up, down, up. As we can notice, we have at x equals -1, it's a maximum because it's going up then down. So it's like this. So this is a maximum. So x equals -1, we have local maximum. At x equals half, we have a local minimum.